Please, welcome to the stage, Datadog Chief Executive Officer, Olivier Pomel.
Good morning, everyone. I'm Olivier Pomel, co-founder and CEO at Datadog, and I'm really excited to welcome all of you to Dash today. If you've seen our keynotes before, you know I won't be very long, as we have a lot to show you. But first, I'd like to thank our partners and sponsors. And you can meet them all on the expo floor. I also want to tip my hat to our Datadog ambassadors for the amazing work they are doing with our community. And most importantly, I want to thank all of you, our users and our customers. I want to thank you for your trust and for building with us. And there is more of you every single day, from every part of the world and every corner of the economy. You represent some of the largest companies in the world, as well as the top teams that are building the future of AI, whether that's building the models, the coding agents, or the apps we all started using every day. So it is a truly inspirational peer group and an amazing opportunity for all of us to exchange and to learn for each other. Now, the past 50 or 60 years have been pretty good for software engineering. And you can see the increase in productivity behind me. My dad was a software engineer. And he actually started programming on punch cards when he was in school. So that would be all the way out to the left there. And ever since then, we've been through revolution after revolution, with higher-level languages, with the internet, the rise of open source, the cloud, and now with artificial intelligence. Progress has kept accelerating, and we do expect that to continue. And so what this means is that we can now build technology in weeks or even days that would have been science fiction just 5 or 10 years ago. That's really amazing. But it also means that we're shipping apps and systems that we don't fully understand, with code that we mostly didn't write, and a lot of components we don't really have a good mental model for. And so what we do end up with is an increase of complexity that is even bigger than the gain in productivity. And because of that, we keep going faster and faster, and yet it doesn't feel like our jobs are getting any easier. This explosion of complexity is precisely the problem we set out to solve at Datadog. And for that, we can't slow down. In fact, we are accelerating our investment in R&D. We invested more than $1 billion last year, and we're going to show you some of what's coming next. So, a big theme today is going to be how we can help you win that race against complexity and help you build autonomy into your operations so that you can ride that beautiful productivity curve and fully enjoy its benefits. And to get us on that path, I'd like to invite on stage my co-founder, Alexis.
Thanks, Olivier. Hello, everybody. I'm really glad to be here with you at Dash today. Last year, I told you that we've always been focused on answering a simple question. How can we help? I also told you that we saw AI as a powerful tool, and we still do. None of that's changed. What's changed is that I feel that every team in this room and beyond is building more, writing more code, shipping more changes, launching more experiments. In short, teams are building at AI speed. So back to my question, how can we help? How can AI truly help? Last year, we introduced Bits AI for SRE, and your feedback has been overwhelmingly positive. Thousands of you use Bits every day to help you understand and fix issues faster and with confidence. This year, we're teaching Bits AI to be helpful in a lot more cases, across every layer of the stack, so that everyone across your organization can move at AI speed too. We'll cover a lot of ground today, so let's get started. We are all writing more code with AI. That's awesome, but writing code is just a small part of the whole process. Because operating software has to keep up with that pace and volume. You cannot review every single line of code, or keep track of every new changes, or understand every new failure mode that's appearing. So the question concretely becomes, how do you ship faster and still deliver experiences your customers can trust? If you're running software like we do, you're in this loop: detect, investigate, remediate. And it can take minutes, hours, or even days. And for years, we at Datadog have worked to help you navigate this loop as quickly and as easily as possible. With Bits AI SRE, we fast-tracked the investigation step, accelerating one of the most high-pressure and high-stakes parts of SRE. Bits is already helping thousands of teams find the root causes of issues faster. You can also chat with Bits natively in Datadog, outside of an investigation. Bits Chat lets you ask, understand, and act across Datadog, creating dashboards, notebooks, triaging issues, making sense of your entire production environment. If you have not had a chance to use Bits Chat, this is what it looks like in action. It's meant to drive the whole platform as you work through a particular problem. And good news, Bits Chat is generally available to all of you today. But Bits AI, SRE, and Bits Chat are just the beginning. Because we know you need more than that. The amount of code, the complexity of modern software stacks are just rising too fast to keep up. So we've built a lot more in Bits. And to kick us off, let's hear from Samantha.
Thanks, Alexi, and hello, everyone. I'm Samantha, and I'm a product manager here at Datadog. For years, Datadog has helped teams answer one of the most important questions in operations: is production healthy? Traditionally, detecting when it's not depends on our teams creating monitors and tuning thresholds and keeping them up to date as our systems evolve. But as we just heard from Alexi, AI is now helping all of our teams ship more code faster. That means production is changing more often. And with all of our amazing new features, also comes more surface area for something to go wrong. So production monitoring needs to keep up. It can't be limited to the monitors that we knew to create ahead of time. It has to detect when something's unhealthy and determine if it matters as production changes. That's why today, I'm excited to announce that Bits detection is now available in preview. With Bits detection, Bits uses your historical telemetry, your service topology and ownership, and source code context to manage your critical monitoring automatically, continuously, through every change. Bits understands what's impactful to your business and what warrants response. But that's enough talk. Let's see it in action. We're looking at an e-commerce app in Datadog, specifically at Checkout API, the service behind the final purchase flow. And at first glance, checkout looks fine. Requests are coming in, latency is reasonably stable, and at the service level, error rate doesn't look catastrophic. But there is an active alert, and it looks like Bits AI caught something our manual monitoring missed. Last week, my team shipped a new feature powering personalized offers during checkout and launching this new endpoint, promo eligibility. Because it sits directly in the purchase path, it quickly became tied to conversion. But Bits didn't wait for us to know what to monitor. It saw the new endpoint appear, understood that it sits within checkout, calibrated its baseline as traffic ramped up, and detected when errors moved outside of that baseline. That is why this is red now. Not because my team predicted the failure, not because we manually created a monitor, because Bits kept monitoring aligned with how the service was actually changing. And as I dig into this alert, I can see that Bits didn't just turn the endpoint red and wait for me to investigate. It kicked off the investigation automatically. And that's where autonomous operations begins. Bits catches the right problem early, with enough context to move directly from detection to investigation, while our teams stay focused on building. We just saw how Bits continuously monitors production to detect impactful issues. With that, I'll hand it off to Anish to show how Bits continues autonomous response.
Thank you, Samantha, and good morning, everyone. I'm so excited to be here today. My name is Anish, and I'm a product manager on Bits AI. What Samantha just showed us is Bits detecting the checkout issue completely on its own. But being alerted on the issue is only the beginning, because now we know that checkout's broken, but we don't know why. It could be because of a traffic spike, a logic bug, a connection issue, a bad deploy. All of these are plausible. But our customers are still trying to buy. So every minute we spend guessing between them is just more failed purchases. For the past year, Bits has helped take this guesswork off of our hands by investigating the root causes of production issues using the signals around our system, like telemetry, service context, deployments, and source code. But anyone here who's been on call could tell you that the hardest production incidents aren't solved by system data alone. They depend on operational knowledge, the things our teams have picked up only after years of running production, like knowing what signals have mattered in the past, or remembering all the things that have failed before, or understanding the nuances that make our environments unique from everyone else's. The problem is, this knowledge is scattered. It's usually in Slack threads, runbooks, postmortems, tickets, docs. So the next time an incident happens, your team may have already learned something in the past that could help you know where to look and what to do this time. That information is probably already out there. But it's impossible for any of us to remember where it all lives and remember which pieces will be helpful, especially in the middle of an incident. And that is exactly why we're giving Bits memory. With memories, Bits now learns from all of the work that our teams are already doing, and it remembers lessons as they land. It also knows what's worth remembering, like signals that my teammates share in Slack conversations during an incident, or recommended actions that are listed in runbooks, any of my team's hundreds, or root causes written down in postmortems. Bits notes these lessons down so that it can bring them back the next time they can help. And memories aren't just for investigations either. Bits brings its memories to all of its work, so the next time it's helping your team with anything, it's starting with your team's knowledge and experience. Now let's go back to that checkout issue that we were looking at earlier, and let's see how Bits investigates using everything it knows. Bits starts investigating by generating several hypotheses at once, and it tests all of these against the live signals around Checkout API. The first thing it sees is that the Pomel eligibility endpoint is failing in bursts. And then, as Bits continues, it remembers something. A different incident with a different endpoint from weeks ago, where the incident initially looked like the root cause was a connection issue. But my team dug in, and they realized that the real culprit was Checkout API pods crashing. Bits captured that lesson when it happened. So right now, nobody's digging through old Slack threads trying to look for that incident's details. Nobody's manually pasting any context into a prompt box. Bits just brings that knowledge directly into the investigation, which tells it exactly where to look next. Pod health. From there, the rest of the investigation falls into place. The error spikes line up with pod restarts, which started after last Thursday's deploy. So Bits goes ahead and checks the code, and sure enough, it sees a new session cache for Pomel eligibility that's growing without bound. And now, within minutes, we have what we're used to chasing for hours, a root cause that we can actually trust. Bits also lays out the whole story step by step. Thursday's deploy added the cache, memory climbed and forced restarts, and the restarts interrupted promo eligibility. So now Bits knows exactly what happened, but our customers are still failing to buy. In other words, the investigation is done, but the incident isn't over yet. And after everything you just watched Bits do, from detecting the issue on its own to investigating it, we thought it'd feel a little bit odd if we stopped here and had someone log on and manually run a fix, which is exactly why we're giving Bits the ability to act today with Bits Remediation. With our checkout issue, Bits looked for the fastest safe path to bring our service back to green. And it lands on 3 immediate options: restarting the pods, rolling back the deployment, or scaling up. But this is production, so before Bits takes any action, it checks the guardrails that my team has set for Checkout API first. These guardrails tell Bits which actions it can take completely on its own and which ones still need a human sign-off. And we'll show you how these are defined in a bit, but for now, the important part is that my team has already given Bits approval to restart pods completely on its own, because it's scoped and it's low risk. So Bits goes ahead and restarts the affected pods to clear the memory pressure, and then it waits to follow the recovery all the way through. Within minutes, memory drops, and checkout is back to healthy. Our customers are back to buying now, but Bits also knows that the bug that started all of this is still sitting in our code base. So Bits goes ahead and writes the code fix as well, and it lets me open a PR with 1 click. Now production's back to green, and my team has a durable fix in hand. I want to do a quick postmortem on the incident that we just saw. Bits caught the problem on its own, investigated it with memory, and acted safely to bring the service back. What Samantha and I just showed you is Bits for SRE. It's incident response that nearly runs itself, and that's exactly what we mean when we say the words autonomous operations. But as good as it feels to fix an incident in minutes, the best type of incident is still the one that never happens. So now I want to hand it over to Jessica to show you how Bits can also catch the routine infra issues that can turn into tomorrow's outages. Thank you.
Hi, everyone. I'm Jessica, a product manager here at Datadog. You just saw how Bits detects, investigates, and remediates when something breaks. But operations isn't just incident response. It's also the routine infrastructure work that teams do daily to keep everything running. Restarting Kubernetes deployments that crashed, troubleshooting network latency and congestion, adjusting Lambdas to prevent timeouts. Individually, these issues are easy to fix. But infrastructure issues are increasingly changing faster than we can keep up. And what you're seeing here is just a sample. Teams may have hundreds of issues in flight that don't always page. And together, these issues compound and get worse until what you're left with is a business-impacting outage. And this is what Bits is always watching for. Not just incidents, but the infrastructure issues that lead to them. Bits helps you get ahead of these with purpose-built autonomous operations for your infrastructure at scale. Every action Bits takes is closed loop and deterministic, so your team stays in control. And today, I'm excited to announce Bits Infrastructure Operations. Let's see it in action. My infrastructure is complex. And here in Datadog, Bits is detecting, investigating, and remediating all the issues across my environment that have been quietly building. Crashing Kubernetes pods, ECS task failures, expiring certificates. Remember our checkout service that Samantha and Anish just walked through? We may have averted an incident earlier, but there are still issues degrading checkout stability. It looks like there's a critical issue, so let's deep dive into the investigation. Here, I can see checkout API pods are getting repeatedly out of memory killed because the memory limit is set too low for peak usage traffic. Each pod restart spikes latency before traffic fails over to healthy pods, making the service less stable over time. So when that memory leak hit earlier, this is exactly what would have made that incident worse. Bits has done the investigation, and the fix is ready. Increase memory to 1 GB. But safety is paramount for any production change. Before I approve this Kubernetes patch, how does Bits know when it can and cannot take action? We know this question is top of mind for teams adopting autonomous operations, which is why today we're introducing Bits Guardrails. Earlier, Anish walked us through Guardrails in action for the checkout incident. Now, Datadog is already embedded in my environment collecting telemetry. But with Guardrails, I can now safely automate fixes for my infrastructure at scale with Bits. Here, I can create a guardrail for any resource, environment, and action, such as a Kubernetes patch in this checkout example. I can ensure my teams are notified in Slack whenever Bits makes a change, whether it's auto-approved deployment restarts or a production patch that requires user approval. And Bits only makes changes within the scope that I've defined. So now I can have Bits patch the deployment to immediately stabilize my cluster and open a Terraform PR so the change persists in code. And every action is logged with full evidence and outcome. But I'm still in the loop here. How can Bits work autonomously for me? Bits sees that I've approved the same action for the service before. Now I can tell Bits to update my guardrails so this action is auto-approved, and Bits will autonomously resolve these issues for me next time. This is how Bits learns, from the changes I've already made in my environment. And now, Bits is also available wherever you work, whether that's in the Datadog app, in Slack, or in Claude Code and Codex, powered by the Datadog MCP server. So that's how Bits helps you autonomously close the loop on infrastructure issues before they become an incident. And now, Bits is a true autonomous teammate, detecting earlier, investigating with full context, and remediating safely on your behalf. And so the entire DevOps loop accelerates. What used to take hours now takes minutes. And that's the shift to autonomous operations for your infrastructure. We're excited for you to try this out. Find us on the expo floor to learn more. And now, I'm going to hand it back to Alexi.
Thanks, Jessica. So we're taking you out of the day-to-day toil that AI can handle, so you can focus on more complex and critical tasks. With autonomous operation, we help you accelerate this loop and free up time for you to build what truly matters. And today, over 3,000 of our customers are already using Bits investigation, and thousands more are using our other AI capabilities, like Bits Chat. And among them is NASDAQ. You all know NASDAQ. It's one of the world's largest stock exchanges, with massive volume, very high rate of transactions, all of which is business critical to the clients they serve. And so, it's my pleasure to welcome Donald Beery, Chief AI Integration Officer at NASDAQ, so that I can share with you his experience with Bits AI.
All right, thanks for having me. I'm here from NASDAQ to share some of our insights on this innovation economy. At NASDAQ, data is at the foundation of how we operate our markets. We serve our clients and deliver trusted intelligence at global scale. As data volumes and complexity continue to grow, our ability to observe, manage, and act on that data in real time is more important than ever. Let's take a step back and look at NASDAQ's business and how we serve our clients. At the core is NASDAQ's modern intelligence platform built on data. We generate deep gold source data across our markets, index, and investment businesses, and then embed that intelligence directly into our solutions. This creates a network effect. It allows us to deliver deep insights and outcomes. As we operate our clients' most critical solutions, we lever this intelligence platform to power their trading, risk management, analytics, and investment decisions. And all this happens at extraordinary scale, from markets generating billions of messages, surveillance systems managing trillions of records, to platforms representing tens of trillions of dollars in assets under management. That scale, combined with trust and intelligence, allows NASDAQ to deliver mission-critical capabilities to clients worldwide. Remember, NASDAQ was the first electronic stock market, and we spent decades advancing and modernizing our best-in-class trading technology. These platforms serve us, our customers, and economies worldwide. To support these platforms, we've always had logging. But logs, they're just an archive of history. As you know, Datadog brings us observability, real-time telemetry, and actionable insights. The ability to look at our system real time and understand what's going on at a transaction level. And since they've added bits, we have the ability for anyone to interact with their platform in natural language. At NASDAQ, Mario Diaz leads our global derivatives platform. These platforms handle around 100 billion messages a day. Every message is in sequence and without data loss. Mario tells me, if you're not carrying bits on your phone, you're not managing your systems. Because bits is integrated into the Datadog platform and lets anyone on our team ask questions in plain English, from which server is slow, all the way down to where is this transaction getting stuck? So at NASDAQ, we see markets evolving toward a more connected, always-on, and intelligent financial system, one that moves faster, settles sooner, and operates with greater transparency and, of course, resiliency. But right around the corner are 24/7 financial systems and tokenization. And these will be the defining features of the innovation economy. And this represents a significant opportunity for NASDAQ and Datadog. Just think about the support that 24/7 platform will demand. It makes that bits application on Mario's phone even more important. Again, realizing this potential will require what NASDAQ is renowned for: trusted exchange-grade infrastructure, reliable, available, scalable, and secure, providing global access to connect investors and issuers to new pools of capital. Today, more than 135 markets and regulators work with NASDAQ as a transformation partner. So NASDAQ is well positioned for this transformation. And with Datadog as our partner, we're excited to accelerate innovation, strengthen our platform, and deliver even greater value to our clients. Thank you.
Thanks so much, Donald. We're so happy to be working with you and supporting NASDAQ. Okay, so we're on our way with Bits AI towards autonomous operations. But to keep pushing towards more autonomy, we need to keep improving our platform. Because the complexity of software systems and the amount of observability data that's needed are rising exponentially. So we want to share with you our latest innovations to ingest, correlate, analyze, and act on that data, whether it's across your networks, your databases, your logs, whether it's on premises or in the cloud. And for that, please welcome Angelina to the stage.
Hi, everyone. I'm Angelina, product manager here at Datadog. We've seen how AI is helping teams operate faster than ever. And as our systems become more autonomous, some things still remain true. Every application, every service, every AI workload, everything still runs on the network. And our systems become more distributed across containers, clouds, and on-premise data centers. Understanding what's happening underneath only gets harder. The problem could be anywhere: a noisy cloud workload, a congested circuit, or a misconfigured firewall. To users, it all looks the same: slow applications. The challenge is knowing where to look. Today, I'll show you how Datadog Network Monitoring helps any engineer pinpoint, understand, and resolve issues across cloud and on-premise environments with confidence. Now, let's look at a scenario that'll feel very familiar. My team operates a fintech application, and at 1 p.m. today, Purchase app fired an alert for an unusual latency spike. With Network Path in Datadog, I get a hop-by-hop view of exactly how traffic flows from my application to its destination across cloud, on-premise, or hybrid environments. I can drill into every hop along the path, whether it's a transit gateway, VPC, cloud resource, or on-premise device. This means I can quickly see where latency, packet loss, or connectivity issues are being introduced. And right away, the problematic hop stands out. NY Edge, highlighted in red, introducing 550 milliseconds of latency. On this path, this seems highly unusual. To validate that, I'm going to compare the current route with the path traffic was taking before the incident. And now the problem becomes clear. Same source, same destination, but traffic is now taking a different route, which clearly identifies NY Edge as the culprit. And because my team monitors our on-premise network infrastructure with Datadog Network Device Monitoring, I can dig deeper into that on-premise NY Edge device. Checking the health of connected dependencies takes seconds in case there are also issues downstream, and I can drill straight into NY Edge's interfaces to spot any spikes and errors without wasting time. Even better, Datadog has already done the hard part for me. It looks like bandwidth utilization on an NY Edge interface dropped from 42% to 5% right at 1 p.m., exactly when Purchase app latency spiked. And there's more. At 12:58 p.m., someone made a QoS policy config change on NY Edge. And that change ended up incorrectly reclassifying critical traffic, causing packets to be dropped just 2 minutes before the incident. That's our root cause. And this is where Bits can really shine. Bits walks through the evidence step by step and explains exactly what's happening. So even if I'm not a network engineer, I can quickly understand the issue, the impact, and the cause without having to decode complex network behavior myself. And it doesn't stop at diagnosis. With Datadog, I can roll the device back to its last known good config with a single click. No SSH, no separate tool needed. I can clearly see the current configuration and compare it against Datadog's recommended rollback state and apply that change with confidence. The change is pushed immediately, automatically logged in the network configuration management timeline, and we can watch in real time as latency returns to baselines. You just saw some exciting new features we're launching today, like how with Network Path, you can instantly compare route changes and pinpoint the exact hop causing latency. With Bits and Network Device Monitoring, you can quickly identify the root cause of issues across cloud and on-premise infrastructure in plain English. And with Network Configuration Management, you can roll back config changes and get your environment restored to a healthy state. And there's so much more we're announcing today. When something goes wrong, Datadog Network Monitoring gives you full-stack network operations, taking you quickly from alert to resolution. You can trace traffic across every network hop, from applications to cloud services to on-premise devices. And you don't have to be a network expert to understand what's happening. With Bits, anyone on the team can pinpoint the root cause. And when it's time to act, Datadog helps you fix issues across every network layer automatically, so your whole team can resolve problems with confidence in a single click. Less finger pointing, faster resolution, and more resilient applications. But the network is not always the issue. To tell you how to fix another common pain, here's Alex.
Hi, my name is Alex Weisberger, and I'm a senior software engineer here at Datadog. I've definitely had outages caused by network latency. But do you know what's been giving me the most problems recently? My databases. Like many of us, that's why I've been using LLMs to help me debug and optimize my slow queries. And they help a lot of the time, but I think we're all seeing how inconsistent they can be. In fact, just the other day, I had to roll back an LLM-suggested optimization because it actually regressed performance. My team and I wanted to quantify this. So we took the top 500 queries from across our services and asked an LLM to optimize them. We got back around 300 suggestions. 300 is way too many for me to roll out to prod with any confidence, because I know that there are outages lurking in many of them. So I would have to spend days running benchmarks to figure out which ones to weed out. So, is the LLM saving me time or causing me more work? I need to know which changes I can trust and which are just theories. Which is why today, I'm really excited to show you Bits database optimization. We built an AI-powered query optimization system where every change gets validated on a simulated database. Let me show you an example. Here I am in database monitoring, looking at my query metrics. The top query has been a thorn in my side ever since it's been deployed. It has the vast majority of total execution time and block reads on this database, and it keeps timing out. But I see that Bits is saying that the query can be rewritten to be much more efficient. Let's take a look. The current query has an OR predicate that references both tables in the left join. And this is preventing the current indexes from being used. Bits is saying that we can instead union each side of the OR together, which should allow those indexes to be used. Now, this sounds totally believable, but I've seen way simpler optimizations not pan out in practice. So here's where I normally would run a benchmark, but now I have to go through the pain of finding reasonable seed data and interesting params. But below, I see that Bits has already run a performance analysis for me. Let's see how it works. Database monitoring already collects my schema data, along with COM statistics that give information about my data distribution. Now, this is the cool part. Bits spins up an ephemeral Postgres container and populates it with generated test data matching this distribution. This means I'm getting realistic benchmarking data without touching any sensitive customer data of mine. On this simulated database, Bits runs my original query against the optimization and measures latency, logical reads, and blocks dirtied. And Bits doesn't just run the queries once and call it a day. It explores the parameter space to capture a diverse distribution of performance in a variety of scenarios. Here, I see a huge performance improvement across multiple dimensions, including average execution time and P95 logical reads. This gives me a lot more trust in this recommendation because I know it was run on a real database engine. However, I still want to understand the cause of the performance improvement under the hood, and for that, I need to look at execution plans, which Bits also collects. So by coming up and clicking the Compare Plans button, I can see the move from sequential scans in the before version to index scans in the optimized version. Now I have the complete picture and understand why performance improved. But we still don't stop there. Bits has already generated a pull request, applying this change against my code base. So whether I'm using an ORM, query builder, or any other SQL generation pattern, Bits database optimization has me covered all in one flow, from detection to validation to deployment. Back to our case study, we can see how Bits database optimization avoids wasted time from LLM hallucination. Instead of you sifting through hundreds of optimization candidates, Bits presents you with validated changes. And we found that this validation harness took those original 500 queries with 300 blind optimization candidates and produced 30 validated optimizations ready to merge. That's 90% less noise with full confidence in what's left. And we think this is the key to employing AI for query optimizations and making sure your time stays on the work that matters. To recap, Bits database optimization finds optimization candidates with AI. It then filters out invalid optimizations with a validation harness that runs queries on a simulated database. And finally, it opens a PR that applies this optimization to your codebase. That's query optimization end to end. Try Bits database optimization today and see us on the expo floor to learn more. And now to tell you about our latest innovations in log management, here's Zara.
Hi, I'm Zara, product manager here at Datadog. Over the past couple of years, you're innovating faster than ever. And while that's exciting, this has led to your telemetry volumes exploding. This also means that that telemetry is scattered across more places than ever. It's in Datadog, it's in your data lakes, and it's in your cloud storage. And when your data is scattered across that many places, every question becomes a full-day workflow. That slows you down, and you end up losing the critical context that you need. Which is why today, I am excited to announce Federated Logs. Search across your observability data, your data lakes, and your cloud storage, all without leaving the Datadog Log Explorer. Let me show you. I'm an engineer on the payments team at an e-commerce platform, and I just got an alert that the payments API error rate has jumped from 0.4 to 6% in the last 90 minutes. I start my investigation by checking what type of error is actually coming back. And I can quickly see that almost all of them are fraud check timeout exceptions. So the payments API isn't just broken, it's actually waiting on that fraud check and then giving up. I'm going to capture this as a finding so that I don't lose track of it. Now, because the fraud check is timing out, I actually suspect that there's something wrong on the model itself. And this is where my investigation normally breaks. The fraud check calls a model which runs in Databricks, and that's where the model's logs are too. Normally, I'd have to switch tabs and restart my investigation all over again. And that is assuming that I have access. But now, with Federated Logs, I don't have to leave the Log Explorer. I can quickly switch the source to Databricks and then to the fraud model logs. I group by confidence score and by merchant type. And I can quickly see that the score for gambling has dropped by almost half. That's likely our culprit. I'm going to capture this as well. Everything I've captured along the way lives in findings, a new feature in the Log Explorer which allows you to save, sort, and analyze your investigations. And now, Bits AI can take these findings for further analysis. And as you can quickly see, Bits has not only helped me determine the root cause, but business impact and recommended next steps. And that is the power of bringing all of your data together, regardless of where it is, with federated logs and findings. But that's not all. For when you want to turn unstructured data into AI-ready data sets for platforms such as Databricks and your cloud storage, you can now use observability pipelines. Observability pipelines allows you to standardize in open formats such as OTel and OCSF, enrich with contextual data from ServiceNow, redact PII, and transform as needed. With this, Datadog has you covered. With federated logs, findings, and observability pipelines, you've got everything you need to search across your data wherever it lives. And to do this, we're partnering closely with Databricks to bring all of these experiences natively to you in Datadog. And here to tell you more is the Databricks CEO, Ali Ghodsi.
CEO of Databricks. Datadog and Databricks actually are very similar companies. We both started around the same time. We were multi-cloud companies, and we wanted to give enterprises optionality. These days, the world is changing. We have AI everywhere, and we're seeing now massive operational logs, metrics, and traces coming into these systems. And enterprises and companies are facing a really bad trade-off. Either they have to make lots and lots of copies of their data to make things work across all these different systems, or they have to silo it, in which case it's not accessible. With this partnership, we intend to change that. You can use Datadog and Federated Logs and access the data that's in Databricks in real time and do your exploratory work right there. You can use Genie and ask questions in natural language from the AI. You can ask questions like, what incidents are hurting my revenue? Or what endpoints are causing drop in conversion rates? Or what latency spikes are impacting the highest revenue customers that we have? Customers are already moving to this architecture, from leading AI companies all the way to the most iconic enterprise companies out there. And the Databricks team is this week at the Dash conference, and next week we'll be at Data and AI Summit. Please come visit us and have a chat.
Thanks, Allie. We're excited about this partnership and doing more together. Moving on. As your teams heavily invest in AI and you're doing business across multiple geographies, many of you are seeing skyrocketing telemetry volumes at petabyte scale. This, along with the compliance requirements across regions, presents many challenges. You need more control and flexibility in terms of how you collect, store, and analyze those data sets. And many of you have asked for Datadog's ease of use and reliability deployed in your own VPCs, which is why today I am excited to announce Bring Your Own Cloud. For logs, metrics, and traces, your data stays in your environment, and everything else is exactly how you know it. The same dashboards, the same alerts, the same Bits AI, and the same workflows that you already know. Let's take a look at how it works. Lately, I've been seeing intermittent errors on my authentication logs, and just like searching Databricks, I can search the cluster from the Log Explorer and filter to those timeouts. And because this is Datadog, everything is connected. I can pivot from the log to the trace and then to the host metrics. And you're probably thinking, what's different here? And that is exactly the point. It's the same Log Explorer and the same easy experience, but running in your cloud and in any region. So wherever your logs live, Datadog has a path. Standard indexing and Flex for the best-in-class SaaS log management. Federated Logs and Observability pipelines are there for when you have data which lives in other systems. And Bring Your Own Cloud for petabyte scale or data residency requirements. One platform, one experience, wherever your data lives. And we're excited to get this into your hands. Thank you. And back to Alexei.
Thanks, Zara. That was really cool. So let me summarize what you just saw. You can understand and fix issues with network monitoring, even if you're not a deep networking expert. You can optimize database queries with bits database optimizations, with the confidence that you're not in YOLO mode. You can also search your data wherever it is with Federated Logs, whether it's in Datadog or other observability providers, data lakes, or cloud storage. And finally, you can extend the data platform in cases where the data just can't leave your environment with Bring Your Own Cloud. Oh, and there's one more thing on the topic I'd like to share with you. It's about metrics. Metrics intake has climbed relentlessly over the past decade. You have kept us very busy. And with that growth comes more questions you want to answer. You want to break down metrics by container, endpoint, by user, by version, by model, many more dimensions. And the result is that cardinality has been outpacing data volume by a wide margin. And that's a problem. But one we've been hard at work to solve for you. So today, I'm happy to introduce infinite cardinality metrics. Infinite cardinality metrics is built for agentic exploration and querying. Gives you the freedom to capture every attribute and dimension, the ones that matter, no matter how high the cardinality. And it's priced by metric name, and it scales with your data volume, not cardinality. So it gives you predictability. If that sounds like something you want to use, please talk to your Datadog account team to give it a try. OK, back on track now. You're all working hard to build and run great software products. But that's not the end goal. That's just a means. The goal is to delight your customers. And that means deeply understanding user experience, which may include millions of users or even billions of users, all using different devices, application versions, networks, etc. It's not easy. And if that's a problem that resonates with you, you're going to like what the next speaker has to show you. Let's hear from Maël.
Thanks, Alexi, and hi, everyone. I'm Mel, and I'm a product manager at Datadog. There is something we all fear. 5,000 votes, 700 comments. Somewhere, on social media, a user is telling the world your checkout is broken, again, and you are hearing about it hours after the fact. SLOs are green, monitors are quiet, services are up, and yet, here we are. Where do you even start looking? Front-end? Back-end? UX? Today, you would check each layer of your stack, and each one might just look fine, but users are still reporting issues. That's the gap. Each component in your stack is only one piece of the puzzle. It cannot tell you the full story on its own. The only way to know whether users can actually complete the jobs of your application is to monitor journeys end-to-end. And a journey, at its core, is just two things. An intent, how users start it, like opening the login screen, and an outcome, when they succeed and are redirected to their profile. Simple in concept, right? But we've heard you tell us the struggle it was to instrument a journey with all the possible steps and variations, and how time-consuming it was to do this for all the journeys you had to track, and how frustrating it was to see the instrumentation you wrote going stale the day after with the next release. And even when you managed to keep up, you still had 3 questions that felt surprisingly hard to answer. What journeys are my users actually taking? How healthy are they, like right now? And when something breaks, what changed? Today, we're closing that gap with Datadog Journey Monitoring. Let me show you how an ops team would use it. Journey monitoring brings RUM, synthetics, and product analytics into one new experience. And here is our journey map that shows every user journey listed on a single canvas. Login, search, add to cart, checkout. These are neither services nor endpoints, but the things users actually do. Take login, for instance. As we mentioned, each journey is just 2 pieces. The start, when users reach our login page, and the exit, when they're redirected home. How healthy is it right now? Well, at a glance, we see how many times users tried logging in, the overall conversion rate, and uptime from synthetics, looking good across the board. We even get context from other journeys, upstream in the flow, telling us where users are coming from, and downstream, where they're navigating next, like searching for a product in our catalog. But login is one journey we already track. The harder problem is keeping up with everything our team ships, new features, new flows, every sprint. And that's why Datadog continuously scans real traffic in the background and surfaces journeys nobody configured, like this one, where users add to their cart some product or AI chatbot just recommended. We did not instrument it. We didn't ask Datadog anything. It just automatically appeared, and it's not looking good. Conversion is trending down. fewer users are completing the flow than before. SLOs covering the journey are breached. Datadog is telling us we have technical errors interrupting our existing tests and real users alike. And because this journey is failing, we can even see the traffic on downstream journeys taking a hit too. So what changed? The answer is just one click away. Bits AI has already kicked off an investigation. Let me open it. And Bits AI found the root cause. The recommendation cards are timing out. It turns out a recent model update pushed latency past our 3 seconds cutoff, so most users actually never see the recommendation. Normally, this would be hours of cross-team triage. Product sees a conversion drop. Engineering sees a healthy service. It takes a war room to connect them. Here, they're both looking at the same investigation. We roll back to the previous model as a quick fix. Conversion recovers, and the journey goes back to green. That whole loop from business impact to technical root cause to fix happened on one surface. Now, let me sum up. Because journey monitoring brings all products together, you always know what journeys your users take. Datadog puts them on the map automatically when your team ships those new features, even the AI flows that are so hard to track. You always know how healthy they are right now, and both from a business and technical standpoint. And when something breaks, you always know why. Because journey monitoring sits inside Datadog alongside your backend telemetry, Bits AI can trace the root cause across the full stack. Engineering and product are finally looking at the same story. That's journey monitoring, and now you can use it too. We can't wait to see what you build. And with this, I'll hand it back to Alexis.
Thanks, Maël. OK, so up to this point, we've been talking about the ops loop. But now, I want to switch focus to the developer side. Because if you're a dev, you too are going through your own loop. Write code, ship it, test and evaluate the results. And with AI, the speed of development is accelerating, but not evenly. For more on that, let's hear from Ruxandra.
Hi, I'm Ruxandra Lewick, Group Product Manager at Datadog. In 6 months, AI-attributed commits have gone from almost nothing to millions, and it's accelerating. In the dev loop, AI is changing not just how we write code, but how we safely release it. AI agents compress the time from idea to PR. But trust doesn't accelerate automatically. The bottleneck shifts downstream to reviewing, releasing, and evaluating it safely. How do we reconcile the speed of creation with the speed of trust? At its core, you want to know, is the code working as intended? To answer this question, today, we are previewing the new Bits AI capabilities for developers. Bits AI follows every code change and validates its behavior in staging, monitors its rollout to production, catches regressions and fixes them, and establishes production guardrails. Basically, Bits AI safely accelerates the entire dev loop. Let's see how it works. I'm a product engineer working on Couch Cache, an e-commerce site for finding the perfect couch. Using AI coding agents, I created an AI shopping assistant. The customer opens the chat, they describe what they want, and they see personalized recommendations. I'm pretty happy with the feature, so I open a pull request and ask for reviews. What can go wrong? I know, famous last words. So I start doubting myself. What if the coding agent missed something? what failure modes it didn't consider. This is when Bit steps in. When a PR is open, it analyzes its expected behavior and builds a validation plan across staging and prod. Bit just validated my PR in staging. I want to learn more about it. Today, we are previewing Bit's release as part of the new capabilities Bit has for developers. This is the Bit's release page, which summarizes my PR progress. Instead of bouncing between GitHub, my CD provider, feature flags, dashboards, and Slack to figure out the state of my change, Bit's release brings it all into one place. At the top left, I can see what Bit automatically detected about my PR's intent and expected behavior. On the left-hand side, I see the validation plan that's going to focus on 4 criteria: correctness, error rate, performance, and conversion. At the top, I can follow the progress of my feature from staging to production. For my AI shopping assistant, the first thing Bit checks is correctness. Does the assistant return relevant recommendations or not? To answer this question, Bit uses its new testing capabilities to create an autonomous goal-driven test that navigates the UI just like a real user would. Today, we are previewing Bit's testing as part of the new capabilities Bit has for developers. Bit's testing opens the staging app and tries to see if it can achieve this goal of my feature without following a predefined set of steps. Instead, it dynamically reacts to the responses of the AI shopping assistant. To achieve this goal, Bit is exploring all possible pathways in the application and autonomously develops very complex testing scenarios. Next, I see that there are no back-end or front-end errors. Latency looks stable as well. Checking conversion will have to wait until the feature reaches production. Across the board, this looks great. So I merged the PR. The feature is behind a Datadog feature flag, which Bits can enable to 5% of users in prod. This has been a pretty productive morning so far. However, in a dramatic plot twist, Bits detects an issue in production. So what happened? Bits reran the same autonomous test, which was validated in staging, but this time against production. And I see now that the AI shopping assistant does not return any recommendations at all. At the same time, Bits has been investigating the issue, and I am curious to learn more about what's going on. Bits found that the root cause is a missing IAM role, and a PR fix is ready to go, which I merged right away. OK, now I'm done for the day. Later, I do get confirmation that everything is working as expected. I can see my conversion rate in production, and people are moving through the funnel, and total checkouts are trending up. Finally, Bits converts the temporary test it created for this PR into a persistent test powered by Bits testing. This is the Bits testing page, which displays all of the runs of my autonomous test. This isn't just a one-off test. Bits is going to monitor this going forward. I want to take a look and see how Bits does this. The goal of the autonomous test is to continuously validate in production that the chat still returns relevant recommendations. Moving forward, Bits testing will continuously run in the background to try to achieve this goal. This is how Bits testing catches the edge cases as your product changes over time. So validation doesn't stop at the rollout. It becomes a permanent guardrail for your features. To recap, when AI accelerates code creation, Trust becomes the bottleneck. Bits AI for developers closes that gap through one connected workflow. Bits release creates and runs validations plans across staging and prod. Bits testing autonomously identifies and executes complex testing scenarios. And finally, when something breaks, and something always breaks, Bits code generates the fix. The results, team move faster through the entire dev loop, from idea to PR to trusted release. We're excited for you to try the new Bits can do for developers. Find out on the expo floor to learn more. And now I will hand it back to Alexis.
Thanks, Rusanda. So with Bits AI, we're making the dev loop tighter and faster. And really, the dev loop and the ops loop, in the end, they both need to speed up. And as we deliver on both of these loops, we help you with what you want to do, moving faster from development to production, from idea to outcome. Wherever it makes sense, we're building AI for Datadog, all in service of making Datadog more helpful to you. But that's not all. We have a lot more to show you. And for that, I'd like to welcome Yanbing to the stage.
Thank you, Alexi. Good morning, everyone. I'm Yanbing. This is my second dash, and I couldn't be more excited to be here with all of you. What you've just heard from Alexi and the team is how we're using AI to help you accelerate your software development and your operations loop. All these Bits AI capabilities are production-grade AI that we build to help you with your production system. And we've learned some important lessons as we build them. For example, AI can look amazing until it hits production. Before you take an AI system into production, you need to answer these questions that matter. First, does it work? Not just in a demo, not just in a benchmark, but consistently, reliably in production for real users. Secondly, is it safe and secure? Can you trust it? Can you govern it? We all know AI is creating new attack surfaces, from prompts to tools and data and code. Third, does it have the right economics? Can you scale it in a cost-effective fashion? We've all heard the horror stories. Teams exhaust their full-year AI budget within just a matter of months. This happens at Datadog. And also, agent may get stuck in a loop. Suddenly, an experiment becomes a six-figure bill. It is time to move beyond token maxing into value maxing. And to answer these questions with confidence, it requires full visibility into your entire AI stack. And the time to take action is now. It's no longer optional. You need to observe it, you need to secure it, more, not less than before. And we have seen this shift happening in our customers who's been adopting the LLM observability product from Datadog. In the past 12 months alone, we've seen a 30x increase in the number of LLM spans sent to Datadog. These organizations are moving AI into production and critical workflows, such as software development, customer experience, and critical business operations. And they do require more observability and more security. And that is what we're building for. Because AI introduces an entirely new stack. At the foundation layer is infrastructure, where precious resources like GPU powers your training and inference. And there is a data layer that fuels training and real-time decision-making. Then comes the model layer, where intelligence is created and refined and applied. And finally, at the agent layer, where AI comes to life in products, applications, and workflows. Every layer generates new telemetry, new risks, and new way for you to get paged at 3 a.m. This is why the second part of the keynote is all about Datadog for AI, how we're helping you observe, secure, and improve your entire AI stack end to end. How about we start with the data layer? Please join me in welcoming Harel to stage.
Thanks, Yanbing. And hi, everyone. I'm Harel, an engineering manager here at Datadog. Over the past year, something has changed with the way people query their data. 9 out of 10 organizations now use AI directly on their data warehouse, including us at Datadog. But your data always has issues. Pipelines can break, schemas can change, and data becomes stale. And now, with AI on top of it, garbage in, garbage out turns into a blazing dumpster fire. And that's why last year we released Data Observability, and it's now generally available. Let me show you how it helps. You can now track every pipeline, every run, and every failure all in one place across Databricks, Snowflake, Airflow, and many more integrations. Datadog will also find anomalies in freshness, volume, schema, and value distribution so that you can catch the bad data before the business does. And with end-to-end lineage, from ingestion through transformation, all the way to your BI, so you always know what's happening upstream and what's downstream. And when something does break, Datadog clearly points out what's wrong. We proactively diagnose issues, provide optimizations to your pipeline, and we even draft a fix so you can apply it directly from Datadog. So now, you can trust your data end-to-end using lineage, quality monitoring, and jobs monitoring. But having trusted data is not enough anymore, because now we have a new challenge. All those AI agents that most of you are using to query your data, they don't have access to shared definitions, they don't have visibility on pipelines, they don't have any data governance, and as a result, you get AI slop at scale. Let me show you what I mean. You have a review meeting in 1 hour, and you need to know your revenue by marketing channel in Q2. So you ask your agent. The agent finds a revenue table, runs a query, and returns a number that looks fine. So you walk into that meeting, but only later you find out that number actually included unprocessed returns and test transactions. Wrong number, looking just right enough to go unnoticed. When you're using AI agents with your data, some answers are right, and some are not. So it's possible that right now, in your company, an agent is handing someone the wrong number. And that's why we built Bits Data Analysis. I'm really excited to show you how it works. Now, because we built Data Observability, Bits now has access to your data warehouse, your queries, your data pipelines. It can understand how you model your business. Now, some BI agents might have access to that. But Datadog has a much wider context, your applications, your source code, your product analytics data, and that makes a huge difference. OK, enough talking. Let's open up Bits Data Analysis, ask that question again, and see what it can do. I'll ask, what was our revenue by channel in Q2? The agent grounds the answer in the data context, automatically built from everything Datadog already knows about your data. Lineage, quality, business definitions, not just exposed tables. It reasons about all this data in one chain, excluding the unprocessed returns and the test transactions, and it confirms the source table is fresh. I'm asking the same question, but this time I'm getting the correct answer. Now with Bits, I can push further. I noticed a drop in revenue last week, but I don't know why. I'll ask, Tuesday afternoon, revenue dipped. Is that another data issue? Bits starts by confirming the data is clean using data observability. The dip is real. But then it does something no other agent can. It looks at the checkout flow using product analytics data and identifies a drop-off in conversions on the checkout page. Then, because it knows which service is powering that checkout page, it can access APM data, and it pulls telemetry for that checkout service and identifies that checkout service latency went up from 200 milliseconds to 4 seconds at 4 p.m. on Tuesday. Finally, it overlays deployment events and ties that spike to a specific checkout that happened 5 minutes earlier. Slow checkout, drop conversions, real revenue impact. And that's great, because now I can go from a vague business question to a specific deployment in a single conversation. But even with trusted data, agents still produce the wrong answers sometimes, because some context only lives in people's heads. And that's where you can step in to help. With Bits, data teams can be part of the feedback loop. You can observe and improve quality by updating the business context Bits has. For example, excluding test transactions from revenue queries. Your company is now curating context and continuously improving how your business answers questions. Bits will keep evaluating the reasoning chain and not just the final answer. So data teams can measure quality and improve it. And since you own the context, you are now using the correct revenue definition. And your agents will stay honest about your data. OK, let me recap what we just saw here. As you keep using AI in your data, make sure your foundations are solid. And that's where data observability helps, with lineage, jobs monitoring, and quality monitoring. And it's now generally available. And as you continue asking agents questions about your data, we're really excited for you to try out Bits Data Analysis. It grounds answers across all of Datadog. It evaluates the reasoning chain, and not just the final answer, and allows you to curate business context so that you get the right answers. So now that your agents have the right context, we also want to make sure that you're using agents efficiently in your organization. To tell you more, here's Matt.
Thanks, Pharrell. Hi, my name's Matt Li, and I'm an engineer here at Datadog. Over the past year, developers everywhere have been rapidly adopting coding agents, from Claude Code to Cursor to Codex and more. And we've seen examples of developers using these tools to great effect, identifying and addressing previously uncovered security vulnerabilities and accelerating development cycles. But broad visibility remains a problem. As we adopt these new tools, 3 key questions remain top of mind. First, what agents are being used in my organization? Second, how much is it costing us? And third, can I help my organization use these agents effectively? To answer these questions, we built the Agent Console. The Agent Console is a single pane of glass experience that now gives teams visibility into their organization's usage of coding agents. Let me show you how I answer the first 2 questions. Here, in the Agent Console, I see aggregated details for Claude, Codex, and other coding agents like total spend, users over time, and number of sessions. I can break all of this data down by team, user, repository, or coding agent. I can also look into details like the number of AI-assisted commits and AI-assisted PRs. All of this helps me understand how my team is tracking over time. But that's not all. To see details of my own coding agent usage, I can drill down in the Analytics view. On this tab, I can look into details of coding agent usage in my teams. And in the User Detail tab, I can map my agent usage and associated costs to my PRs. And if I want to understand AI usage at the organizational level, this scatter plot helps me identify different user cohorts. For example, the cohort in the bottom right may have insights to share with the rest of the organization about using coding agents efficiently. And the cohort in the top left may be using coding agents for tasks other than coding, and hopefully aren't simply token maxing. Worth a follow-up just in case. And to make sure we avoid runaway costs, I can set up alerts on my team's usage, helping us to not spend our entire 2026 AI budget in 1 month. With these views, the Agent Console gives me a full inventory of my team's agent usage footprint, which agents are being used, for what purposes, by whom, and how much it's costing. This is great, but as a developer, I would really like to be able to help my team use these agents more efficiently, not just look at cost and usage dashboards alone. Let's take a look at how I do that directly in the agent console. In this page, I'm seeing detected problems in my coding agents because I have set up to detect, via metrics, patterns of agent behavior. I can see how these detected patterns map to coding agent sessions on the left and across repositories in my code base on the right. So let me click and see what the issue is. I've specified a marker to detect the pattern of behavior where my coding agents try to commit or PR code without testing first, which we're calling skip checks. Looking specifically at sessions in my team's Helix API repository, I can see that my teammates have run into the same issue. So how can we fix this? The agent console enables me to see a collection of fixes authored by teams across my organization to address this agent behavior. I can explore these fixes, understand how they work, see which agents they impact, and decide which fixes I'd like to propose to my team. This fix takes the form of a pre-tool use agent hook to remind the agent to test code before committing. And the fix below is an agent skill for testing. And if I want, I can also author my own fix by clicking this button. Once I'm happy with the fixes I've selected, it's just one click to create a PR with my selected fixes to my team's repository, where they will take effect once merged for future agent sessions. And that's how the agent console can help us make our teams more effective and impactful with agents, along with helping us understand more about our AI usage and spend. We're just getting started. We'll be expanding to business agents like Claude Desktop and ChatGPT next to ensure you have full visibility into your agentic stack. We're excited for you to try out Agent Console. Sign up today and learn more by visiting us on the Expo floor. Now, I'll hand it back to Yanbing.
Thank you, Matt. I love how Agent Console is providing the needed visibility and governance in how we can help you use AI efficiently and productively. Few companies understand the challenge of running AI at scale than Modal Labs. Modal is at the forefront of the AI infrastructure, helping customers scale, training, and inference without any operational complexity. To put it plainly, they know how to make GPUs behave. So it's my honor to welcome Akshat Bubna, CTO and co-founder from Modal, to the stage to tell us how they're doing it. Welcome, Akshat.
Thank you. It's great to be here. I'm Akshat, co-founder and CTO of Modal. When we founded Modal 5 years ago, this is before the whole explosion in Gen AI, we set out to build infrastructure designed from the ground up for how data, AI, and ML applications really behave. We wanted to build infra that scales up to thousands of GPUs with a developer experience that feels like running code on your own machine. And it turns out the bet landed at the right moment because the world needed a lot of GPUs and CPUs. And over time, Modal became a whole platform of primitives for the model lifecycle, from inference to training to batch processing, and the agent stack, which is sandboxes and persistent file systems for agents. And this means we run infrastructure at significant scale. We run hundreds of thousands of containers across 17 cloud providers, and we move more than 100 petabytes of data every month. And we do this to power workloads for companies like Suno, Cognition, Ramp, and DoorDash. And as we built Modal, we realized that AI workloads break our mental model of observability. This is because requests last milliseconds. There are millions of them every second. And each one gets sent to a different container, on a different worker, to a different cloud, by a different proxy, and so on. This means that there's a combinatorial explosion of tags associated with metrics. And this is where the new infinite cardinality metrics from Datadog have been game-changing for us. Before this, it wasn't really feasible to do monitoring at our scale, at least in a granular way. And beyond this, Datadog has been powerful for us in a few different ways. First of all, it's been truly a single pane of glass for us. We chase GPU capacity wherever it lives. So Datadog unifies our 17+ cloud providers. And this means we get infra, traces, and logs, so our engineers are not context switching between consoles. Second, Datadog network monitoring, which you heard about earlier in the keynote, matters a lot for us. Given how much data we move, which is 100 petabytes a month, it's really important for us to have a deep understanding of where the flows in our network are and how much they're costing us. And third, we use Datadog MCP really heavily. A surprising amount of internal SRE work for us now runs through agents plus Datadog MCP. It's actually all you need, and it's changing how our team operates. And finally, the Modal integration with Datadog has been really valuable for our joint customers like Reducto and Substack, because they use it day in and day out to see how their Modal workloads are working in their own Datadog instance. So if you're building seriously on AI today, you're probably running fundamentally different infrastructure than you were 2 years ago. And it's not just about having the most compute. I think having visibility into your compute and your AI workflows is more important than ever. This is why we're excited to continue to partner with Datadog. Thank you for having me.
Thank you, Akshat. What Modal is building is a great example of what's required to run AI at scale. Highly efficient infrastructure, optimized GPU, and also unified visibility across their 17 and growing cloud environment. We're proud to partner with Modal. We have talked about data and infrastructure. Let's move up the stack to agents and models. How do we make sure models and agents are working well in production? How do we know they're generating the right business outcome? And how do we know they're making the particular type of decision they're making? This is where agent observability becomes essential. Let's find out more from Charles.
Thanks, Yanbing. And hi, everyone. I'm Charles, PM at Datadog. We're all racing to ship agents into our products. But the definition of an agent has changed. It started simple. You take an LLM, you give it an input, generates an output. But now, agents are autonomous loops that can use skills and tools and even take actions on your behalf before answering. And your agents have evolved, and so did we. We've expanded the scope of LLMs to cover the full agent observability. Now, by nature, building an agent is hard. Users can ask them anything, and agents, they decide what they do when they want to do it. This means shipping an agent that you can trust requires a continuous workflow. Develop, monitor, and iterate. To help you prove that your agent works before you ship it, we built annotation, dataset, and experiment. And to see how it behaves in prod, we built agentic tracing and online evals. But the reality of it is that it is impossible to cover all of your users' behaviors and all of your agent behaviors. And so the right mindset becomes being able to answer these two questions really quickly. What should I improve first, and how do I fix it fast? So let me show you how agent observability answers these questions. The team at TaskCruncher built an awesome AI assistant. We have tracing in place. We have a golden data set with realistic scenarios. And our evals are green. But this morning, I woke up to a nightmare. We had a $50,000 budget, and we've already blown it. I hope my boss hasn't seen it yet. OK. So now I need to fix that, and fast. But nothing has changed. I haven't updated the agent in weeks, and traffic has been stable. So where should I look? To answer this question, we build patterns. It auto-clusters your traffic, surfaces what's new, and highlights what matters. So let's see it in action. Patterns classified 15,000 traces into the 6 topics I was already tracking, like task creation and status updates. And it surfaced 3 new ones in yellow. And I need to know where that cost is coming from. So I've set the graph to show volume versus cost. And coordination is way above everything else. It's a new user behavior, and it's $20,000. This is bad. But at least I know now where it's coming from. So let's dive deeper. The description tells me that users are asking the agent to coordinate work across multiple projects. And this is not something that we've designed or tested the agent to do. And looking down, list tasks is called 15 times more than any other tool. This is weird. Like, the agent shouldn't be doing that. So what's wrong with my agent? OK, so patterns has now helped me figure out where I should look, coordination. But I'm not done yet. I need to understand why it's happening, and I need to fix it fast. And normally, that would be a painfully slow process. You read traces, make a hypothesis, update your prompt, update your dataset, and finally test it with an experiment. It is at least a day of work, and I don't have that time. My boss is there. That's why I'm happy to announce Bits Evals, the agent that debugs your agent. Now, going back into Datadog, I can see that Bits has already analyzed the cluster and has found the root cause. This system is looping. It calls list tasks over and over again instead of fetching all of that data in one go. So I have Bits fix it. In one click, Bits update the prompt. That's easy, right? But if I test this new prompt on my current data set, I will learn nothing. We got here in the first place because my golden data set didn't know about the coordination behavior. And this is why we designed Bits to flag and fix dataset gaps. So I have it add traces from the cluster. Perfect. Now the golden data set actually has what users are actually doing. I open the PR. Because my experiment harness is already wired into CI, the agent automatically runs against every single topic in the golden data set. And now the experiment is complete. So let's see the results in agent observability. Now, that's my type of screen. The new config bits the baseline across every single evaluator. Cost dropped by 20%, tool calls are down, and quality holds. That means we got rid of that looping, and we're good to go. So we went from that crazy $50,000 bill to a fix in minutes. Patterns revealed our blind spot, Bits generated fix, and the experiment proved it. This is agent observability. One loop to ship reliable agents fast. And now, back to Yanbing.
Thank you, Charles. What Harel, Matt, and Charles showed you are just some of our latest innovations. And they're part of something much bigger. We have built a full set of capabilities to help you observe and improve every layer of your AI stack, from GPU monitoring to full lineage data observability to agent console and also agent observability. Because running AI in production isn't just about optimizing one component. It's about having everything work well together. And that is the power of full stack visibility. But we also know full-stack visibility isn't just essential for observability. It's also the foundation of security. We often say you can't secure what you can't observe. When observability and security come together with shared data, shared context on a unified platform, magic can happen. One of our customers has just done that. Let me welcome Jason Taylor, Head of Cybersecurity at ArcXP, the tech platform at the Washington Post.
Hi, I'm Jason Taylor, Head of Cybersecurity at ArcXP. The Washington Post built ArcXP to solve its own publishing challenges. We evolved that into a platform that runs more than 2,500 sites for hundreds of media customers, serving billions of unique page views per month. A secure and stable ArcXP is more than an engineering responsibility. We are safeguarding the reputation of one of journalism's most recognized institutions and the credibility of every newsroom we serve. ArcXP powers some of the world's biggest newsrooms, so an outage isn't just downtime, it stops the flow of news. That's why we stopped treating platform reliability and security as separate problems. They're two sides of the same customer promise. Every newsroom built on ArcXP can publish safely around the clock. This promise motivated us to consolidate on Datadog as a single platform for observability, security, and incident response. With Datadog, every team gained a real-time view of platform health and a single workflow to manage incidents. Complex investigations shrank from hours to minutes. Customer-impacting incidents dropped 86% year over year. The hardest part of running security isn't finding the issue, it's getting it fixed. So we built our security stack on the platform that our engineers were already using. Security, SRE, and engineering now work from the same timeline. Once that foundation was in place, we layered on an AI SOC analyst. Today, it performs the initial investigation on every alert and resolves 89% autonomously. We're adapting to a world where the time to discover and exploit a vulnerability is shrinking to minutes. A consolidated platform is the foundation, and AI is the force multiplier. The capacity we gained is what let us ship Ask the News and our agentic editor and composer products. These are AI experiences that bring agents and journalists together to tell richer stories, with agent observability watching model behavior. Our engineers now spend their time building the future of journalism, not managing the tools that protect it. The next chapter of media will be defined by how quickly publishers adopt AI safely, at scale, and with trust intact. We intend to lead it, and we intend to do it with a partner whose pace of innovation matches our own. Thank you.
Thanks, Jason. Hi, everyone. I'm Tim Knudsen. I lead our security products here at Datadog. We're proud to partner with ArcXP, the Washington Post, as they build the future of digital media platforms. What Jason described is a powerful example of what becomes possible when observability and security work together on a unified platform. And that brings us to our next topic, security. 2.3 years. That was the time it took an attacker to weaponize a security flaw. With AI, it's a day or less. Why does this matter to you? Congratulations. You now have 3 new challenges on your list. 1, AI agents. They've created a new way for attackers to get in. Prompts, data, the developer tools that are being used, coding agents. How do I secure them? 2, the vulnerability backlog continues to grow uncontrollably. But which of these actually matters the most? 3, threats unfold at machine speed. Investigations still take hours. How do I defend against AI scale attacks? Let me show you how Datadog security can help with all 3. First, let's talk about securing AI agents. When an agent gains access to your company's private data, a single malicious prompt from an untrusted source can turn the agent into a target for leaking sensitive data, credentials, source code, costing you millions, reputational damage, or data loss. This is known as the lethal trifecta attack. To help you defend against this, I'm excited to announce Datadog AI Guard for custom agents. Now available, AI Guard secures your homegrown agents with runtime protections. See, custom agents, they interact with a wide variety of models, tools, data sources. What AI Guard does is it integrates directly into that agent flow. It intercepts every agent interaction. Then applies AI, behavioral analysis, to detect or block attacks, like malicious instructions sitting inside of an API payload and other data sources. So the attackers can't exploit that agent. They can't exfiltrate data. So let's take a look at AI Guard in action. Let's look at an example of a fintech company that's building an autonomous expense review agent. In AI Guard, the first thing I see is a prioritized list of security signals. So I know the security threats that matter the most. At the top of the list, we see AI Guard automatically blocked a high-severity prompt injection attempt. AI Guard detected the attacker had malicious instructions in a receipt in an attempt to exfiltrate data. But thanks to AI Guard, this was blocked in real time. But how did AI Guard figure this out? In this view, we see how AI Guard is inspecting every interaction, both the input and the output. The expense agent loads the latest expense policy, looks at pending expenses, and finally processes the receipt. But when I look at the receipt, it looks harmless, but this attacker was a bit sneaky. AI Guard identified payment instructions were different than usual. The receipt included instructions to override the default model behavior and send 90 days of transaction data and employee account numbers to an attacker-controlled email. But in this case, the attack was blocked, all thanks to AI Guard runtime protections. Now, let's talk about a surface that has grown, or may say spread exponentially over the last year: the developers' coding agents. Coding agents like Claude Code, Cursor, Codex, they now execute source call skills, call MCP servers right inside your SDLC. That puts the developers in the blast radius for the supply chain vector, and this is creating a lot of nervousness amongst your security teams. So, to keep you moving fast, with the right security guardrails in place, we're introducing AI Guard for coding agents. Let's look at how this works in practice with AI Guard hooked into Claude Code. Here inside of Claude Code, I'm running a skill I downloaded in my team's repo. It's an innocent-looking pull request summary skill. But hidden inside is a dynamic context command that runs before Claude even sees the skill, which could lead to critical supply chain compromise. The skill is designed to grab my GitHub token and steal it. But AI Guard intercepts and blocks this command before the token even leaves the machine. Simple as that. OK, so we've secured a known agent. But to protect our full environment, we need to see every agent. And that's where AI Guard Agent Discovery comes in. It maps every known agent in your environment, so you have full lineage visibility across model endpoints, data sources, dependencies, and what is protected and what is not. In the Discovery view, I can see both protected and unprotected agents. Here we see some of the agents are calling an unsanctioned DeepSeek model endpoint. Let's click here to see which ones. It looks like it's calling a set of DeepSeek models that we haven't allowed in our organization. Even worse, AI Guard is showing threat signals on this AI service. This is telling me it's actively under attack. It also has access to sensitive data, increasing the severity of the situation. But with AI Guard, I can simply click, protect this agent, and remove the risk. All right, next up. let's talk about challenge 2. What vulnerabilities matter the most? Even with strong prevention, vulnerabilities are going to end up in your runtime. And when that happens, the backlog explodes. Everyone here who's been handed a list of 1,000 CVEs, told to go fix them, knows exactly what I'm talking about. The problem isn't about finding more. It's about figuring out which ones matter the most. And to solve this, we need runtime behavior, reachability, business impact, ownership, all in one engine. That's why we're introducing the Runtime Prioritization Engine. Let's see it in action. Here's the Cloud Security Summary page. 16,000 CVEs in my backlog, which I'm not going to get to. But the prioritization engine has already isolated down and reduced the noise. It automatically found those that are the critical CVEs that have the high risk of being exploited are actually running on my crown jewels. This is Datadog's real-time visibility in action. This is observability and security together. This is the Datadog difference. As a result, 16,000 becomes 9. Let me click into one, and let's learn more. Let's see how the decision was made, and let's see what else was provided to help speed remediation. Here we see the Spring 4-shell CVE. It's been identified as critical severity with very high exploit probability. Here I see the live ownership details, straight from the infrastructure telemetry, not from some stale code owner's file. Here I see the shipping service has been flagged as a crown jewel. And this is not because somebody tagged it 6 months ago. It's because live APM traces are showing it handling sensitive data right now. Let's look at the reasoning. Production resource, exploit available, high exploitation risk. Based on this reasoning, it's super clear. 16,000 to 9. This is how Datadog ensures you're spending your time where it matters the most. OK, let's talk about challenge 3. How do I defend against AI scale attacks? Let's be realistic. Even with prevention and prioritization done right, attacks will happen. And we all know that dreaded feeling of getting the call at 2 a.m. and being pulled into a security incident. With agentic power attacks, dramatic increasing volumes, it's only going to get worse. That's why Bit's security analysts, autonomous investigations, help you battle AI with AI. Today, it's generally available with the Datadog Cloud SIEM. But now, I'm excited to announce Bit's security analyst runs on top of non-Datadog SIEMs. So you can get the benefits of the Datadog agentic SOC and start helping you today, regardless of what SIEM you're using. Here's an example of it in action. An IAM signal just fired. An AWS admin access policy attached to the developer's user account was detected. Bits pulls the user activity, checks whether the workflow looks console-driven, validates geographic consistency, and weighs this against other concerning signals: residential IP, high privilege grant, missing MFA. It generates hypotheses as if it were a senior analyst. Is this routine admin workflow? Is this a compromised credential? Is this an insider? Every step of the reasoning is visible. It's not a black box. And here's the verdict: high confidence, benign. Reasoning, evidence, supporting signals, all there. Now, imagine this running on every one of your security signals, across all your queues, at machine speed. So let's recap. We started today with 3 new challenges on your list. AI agents are a new way in. Now you have runtime protections. The backlog is still growing faster than you can fix, but now you only have to chase those that matter the most. AI scale attacks outpace your queue. Guess what? Bit's AI security analyst is there to help you battle AI with AI. 3 challenges, 3 solutions, so you can stay focused on shipping. But there's much more we're announcing today across our security portfolio, including Bit's AI Threat Hunter, API testing for app and API protection, as well as AI native SaaS. So come check us out in the security zone. We look forward to seeing you. And with that, let me hand it back over to Yanbing.
Thank you, Tim. And thank you for sticking around with us. As you have seen, we are building a lot We call all of this Datadog for AI, the end-to-end stack that was observability security to help you have the confidence that when you launch your AI into production, you know it's performing, it's secure, and most importantly, you have full control and visibility into their performance and cost. So let me recap the entire keynote. Alexei started with AI for Datadog. We talk about how we're using AI to help you autonomously detect, investigate, and remediate issues in your operations loop. We're shifting left to take that automation also into your software development loop with Bits code, testing, release, so you're shipping code at AI speed. We're also investing in our core platform with new capabilities like federated search, bring your own cloud, and network monitoring, database optimizations, and journey monitoring. Also, let's not forget, for years, there was a 4-letter word in observability called cardinality, until we decided to put infinite before it. So there you have it, AI for Datadog and Datadog for AI. 2 flywheels, 1 platform, and lots of new capabilities. But wait, that was just an overview. We launched so much more capabilities and features, all at Dash this week. Actually, 170 of them. Last year, we had a plain text slide. This year, we decided to turn them into stars in this beautiful galaxy. So this is an incredible moment for our engineering teams, but we're most excited about delivering all these capabilities to you. We're not here to just give you more tools. We're here, as Olivier mentioned earlier, to help you achieve autonomy in your development, operations, and security. Thank you for spending your time with us this morning. Have a great Dash, and go Knicks!